Hey guys, good morning.
Morning, sir.
Morning, sir.
Well, guys, I really hope that you guys are well and thank you for coming out on time. I'm gonna give the others maybe just 5 more minutes to come in and then we begin at about 10 past. All right, cool. All right. Let me ask you, how many of you feel comfortable with the arithmetic progression? I know we finished arithmetic and we move and we start off the geometry, but as promised, I will finish the geometry today. But just checking to see how many of you are feeling comfortable with it.
I'm okay with it, sir.
Mm-hmm.
Just practice. I'm okay with it.
Right. Okay. All right. I'm happy that you are. All right. So for the arithmetic progression, we have something that is called a common difference. How do we find a common difference? Mm-hmm. Oh, maybe I'm muted. No, I'm not. How do we find a common difference in an arithmetic progression? Hello, somebody.
So in the arithmetic progression,
Yes, Taj. Mm-hmm. If you're given a sequence or a series and I ask you to determine the common difference, how do you do that? That's what I'm asking.
Sir, what was the question again?
How do you find the common difference in an arithmetic progression? You have no right. Mm.
Sir, just a minute.
Remember, I have other things to do here, so just answer quickly for me, please, guys. Hello.
Sir, I'm not really what is it now?
Understanding what I'm
Understanding
asking?
the question. Yes, sir.
Sir,
Okay.
is it when we subtract like the last number from the first number? I'm not sure.
All right. Thank you, Georgie. So you're going to subtract, you're going to find one term and subtract a term that comes before it.
Thank
So to find the common difference, you are going to select a term and subtract the term that comes before it. We say the preceding term. So we select any term and we subtract the term that comes before it. Now, I ask that question because in the multiple choice, they will give you a series of a number of sequences or series and ask you which of the following is in arithmetic progression. They will say which of the following is in arithmetic progression. Now, you can't just look at it and say, oh, the answer is A. You have to check it. How do you check it? Based on what Georgie says. Find a term, subtract it from the previous term. But hear my question now. When I get a term and subtract it from the previous term, can I just get an answer like that? What do I have to do to say that it's in arithmetic progression? So yes, we're going to take one term and subtract it from the term before. But how can we convince ourselves that it is in arithmetic progression? By observing what?
So the answer that you get when you subtract it, sir, the common difference, sir, would determine if it's an arithmetic progression because it would be the same answer that you're constantly getting.
Okay, so I'd have to do it more than once in order to see that commonality, right?
Yes, sir.
Okay, so that's what I was asking, right? So you can't just do one to say, oh, I got two, so the common difference is two. No, you have to do it with different terms to see if you get the same commonality in its difference. When you do it several times and get the same answer, then you can say it's a common difference. So that, for example, I can't say, if I'm comparing something, I can't just have one thing to compare. I have to compare it with more than one. All right. So if I'm comparing something, the comparison will have to be with more than one thing. I can't just say, oh, I have an apple, but it's big. Being big is very relative. Very relative. Now I'll have to compare it with another apple to say this is the situation. All right, very good. All right, thanks for answering. Now, my question is, how do I determine the common ratio in a geometric progression?
Sir, to be honest, sir, I don't remember.
Right, no problem.
So I thought we divided for the common ratio
Very
for that
good. So
progression.
for the common ratio, we're going to divide. Very good. We're going to divide for the common ratio. So similar to what it is that we do for the geometric, for the arithmetic, I'm sorry, we're going to do for the geometric. Meaning that we are going to take one term and divide it by the previous term. But we can't just reach it one. We have to do it with at least two of the terms. So I'm going to find another term and divide it by the term that comes before. Another question that comes to mind. When I'm trying to determine the common difference or the common ratio, can I select the first term to decide if it's a common difference or a common ratio? Can I select the first term? Guys are taking too long to respond to me. I have to move on. We have one more week and I have a few more things to cover. The question is, can I use a first term in an AP or a GP to determine the common difference or the common ratio?
Sorry, you can use it, sir, but you can't use it only. You have to use another term.
Okay. Anybody agrees with what she says? Anybody agrees with what Donnie says?
Yes, sir. You'll have to use the next term to the first term to work out the common difference or common ratio.
What do you mean? But explain what you're saying. Because your explanation is totally different from, anyhow, go ahead. Explain to me, expound on that. What do you mean by that?
Also, I meant I can use the first term, but you'd have to use the term next to it.
Which term is next to the first term?
Oh, yeah.
Is there any other term after the first term or before the first term? Talk to me now. Is there any other term before the first term?
No, sir.
No,
All
sir.
right, very good. So can you use the first term now in order to determine the common difference or the common ratio?
No, sir.
Right, very good. So you have to use any other, you can use a second term, because if you use a second term, no, you can subtract it from the first term, as in case of the arithmetic progression. Or if you're using the second term, you can divide it by the first term, as in the case of the geometric progression. But we can't select the first term to check the common ratio or the common difference, because remember, we either have to subtract it from the previous term or divide it by the previous term, depending on which of them we are working with. So we can use any other term in a sequence or series, but we can't use the first term. Is that clear?
Yes, sir.
All right. I'm just quizzing you to make sure that you fully understand this stuff, because these are things that will help you to move on. All right. How do I evaluate the last term of an arithmetic progression, what do I use? What formula do I use to evaluate the last term of an arithmetic progression?
So,
Talk to me now.
it's L equal A plus bracket take N, bracket. Let me start over. It's L equal A as in apple plus bracket N as in Nancy, take 1, close bracket D, which is the common difference, and A is the first term.
All right, very good. So to calculate the last term is going to be L is equals to A plus N minus 1 times D. A plus N minus 1 times D. All right, very good. That's what we use to calculate the last term. How do we calculate the sum of an arithmetic progression? How do we calculate the sum of an arithmetic progression? How do we calculate the sum? What formula do we use to calculate the sum of an arithmetic progression?
So it's S subscript N, and N is the number of terms, and then equal N over 2, open bracket A plus L.
All right, very good. Now, I'm happy that you say the one with the A plus L. What if I'm not given the last term, then can I use that one?
If you're not given the last term, sir, yes and no.
Okay, if you're not given the last term,
You can use, yes, you can use this one, yes, and you can use this one, no. Why I say that, sir, is because you can use the other formula to find L, and then you can use this one.
Okay, all
So
right.
if you don't know the other formula, you can't use this one.
Okay, but is there another sum formula? You're correct, but is there another sum formula?
No, sir.
Is there another sum formula, class?
That I know.
Is there another formula for the sum? You were in class last week, and I mean, you guys were doing very well, so I don't know what it is suggesting to me then that you're not doing any revision, because you were in class last week and you did very well last week. If you were to ask me, very, very well in calculating the arithmetic progressions. So is there another sum formula? Donnie gave us S subscript N is equal to N over 2 plus A times A plus L. Is there another formula? Donnie says no, but I'm asking the rest of the class, is there another formula? Talk to me now. I need to move into other areas, you know. Okay,
So
so go ahead.
I thought there was only one formula if you don't know if you don't know the last term and you want to find the sum of the series.
Right. I see you post it in the chat. Tell us what it is.
So if you want to find the sum of the terms in the series within the series and you don't know the last term, you use n over 2. Sorry, you use the term the last term you're trying to find, divided by 2, bracket 2 times the first term plus the term you're trying to find minus 1 multiplied to the common difference.
Very good. All right, very good. So n s subscript n is equal to n over 2 times 2a plus n minus 1 times d. So both of you are saying the same thing. So Donnie would have, so if I give a question, Tajay, you'd finish a question in 2 minutes, but Donnie again finish a question in 6 minutes. And both of you would get the question right. But what Donnie would have done is to go ahead and find the last term first, and then come back and do a second calculation to go and find, use the formula a plus l times s n over 2. So I'm saying, Donnie, it is much easier to determine, am I given the last term? If yes, I can use the sum with the a plus l. If I'm not given the last term, I'll just move to the other equation to save time. Because remember, in doing any examination, we are working against the clock, and of course, not just speed, but speed with accuracy. Speed with accuracy. So I keep saying to myself when I was going to school that, it don't make sense I spend half an hour. I mean, I was a very slow math worker. When I say very slow and meticulous. But when I finish a question, it knows I'm going to get full marks for the question, because I do the question and then I sit down and I check it over. So I could never ever finish a math paper. I couldn't finish a math paper, but guess what? I used to pass my math exams, but I couldn't finish a math paper. But every question I would have done on a math paper, would I get full marks for it? Because I was working so slow, and I know that was my downfall. So I had to start working very fast and see if I can complete the stuff. And of course, many times I do that, I make some careless mistakes. Either leave off a negative sign or leave off the square of something, and I'll be penalized for it. But the point I'm making though is we have to be working a bit faster than how we are working now, maintaining the accuracy, all right? Because for your exam, you're given 3 hours, I believe, to complete the paper. Really,
Sir,
2 hours?
I was asked about that, sir, because I have HRM and Precal on the same day, on the same time.
Same day, same time?
Yes, sir.
Lord have mercy. Lord have mercy. All right. You need to touch base with the assessment services unit immediately. When I say immediately, send them an email or call them on Monday to let them know that you're one of those students who have a clash with HRM and Precalculus, because this is only the second draft.
Yes,
Only
sir.
the second draft, and chances are, when they communicate this to CCCJ, chances are CCCJ can make an adjustment. But if the adjustment can't be made, exams will need to know so that you could be quarantined. Lord, I hate that word. Jesus, I'm sorry. I hate the word. I think I've been living my life in quarantine since March of 2020. So exams will tell you which exam to do first, right? So you can't just decide which paper you're going to be doing first. So you have to communicate that with exams.
Okay.
And yeah, so just do that for me, please. Very important. Very, very important. Very, very important. Alrighty. There are only 1, 2, 3, 4 of us, but where 2 or 3 are gathered, there he is in the midst to bless us. And I am asking the Lord for a serious blessing this morning over your lives as we go through our stuff. All right, so we're looking at the geometric progression. I don't know why I would have it like that though. Okay. No, I know why I have it like that. All right, so let us look at the geometric progression. So the first term is denoted by A. The second term is denoted, sorry, the common ratio is denoted by R. The last term for AP is going to be denoted by L, similar to that of a GP. The last term of the first term is denoted A, similar to that of an AP. So AP and GP has a first term A, AP and GP have the last term L, AP and GP have N as the number of terms. AP and GP have Sn as a sum of terms. The only difference is that AP has a common difference while GP has a common ratio. GP has something that will go further in that is called the sum to infinity. GP has something that is called the sum to infinity. What is this sum to infinity? When we are calculating the common ratio, and if the common ratio is less than 1, if the common ratio is less than 1, it means then that the sum, that the sequence is converging. Uh-oh, sir, big word, what converge mean? It's getting smaller and smaller and smaller and smaller. And at some point in time out there, it is going to turn up to 0. So I'm able to calculate the sum to infinity, meaning the total sum of all the terms out there. So, but if the common ratio is greater than 1, I cannot evaluate the sum to infinity because the sequence or the series is diverging. So when I have the ratio being greater than 1, it is getting bigger and bigger and bigger and bigger and bigger. So I can't find the sum to infinity if the common ratio is greater than 1. But the sum to infinity I can find once the common ratio is less than 1, because in that case it's divergent. In the other case where the common ratio is greater than 1, sorry, when it's less than 1, it's convergent. But in the other case where it is greater than 1, it is going to be termed as a divergent sequence or a divergent series, meaning that it's going to get bigger and bigger and bigger and bigger, and you don't know how big it can go depending on where it is that it's going. All right. Okay. So now, look at that for me, please. All right. So we did that last week. And so I want you to just refresh your memory on something. When we speak of the first term, it's going to be A. The second term is going to be AR. The third term is going to be AR squared. The fourth term is AR to the third, so forth and so on. So the last term is going to be AR to the n minus 1. It's going to be AR to the n minus 1, which is that. Because we're subtracting 1 from the number of terms, similar to what it is that we did for the arithmetic progression. So what is important is to remember that when we're speaking about the geometric progression, that we are dividing one term divided by the previous term. For the arithmetic progression, one term subtract from the previous term. All right, that's what is important to remember. And so I put a note there and read. For an arithmetic progression, we subtract to determine the common difference. We, however, divide terms in a GP to determine the common ratio. Okay, so let us move back now to that example. Given 1, 3, 9, 27, 81, we need to evaluate the sum of the first 5 terms of the geometric progression. The sum of the first 5 terms. Well, we can check it, 1 plus 3 is 4, plus 9 is 13, plus 27 is going to be 40, plus 81 is going to be 121. So I will have 121 for my sum. See there? But what if they ask you to find the sum of the first 50 terms? You ain't sit down and add up all of the 50 terms? No, absolutely not. Because that's what I was talking about. Taking too much time to do one question that carries a certain number of marks. So a question like this will carry 3 marks, 4 marks, no more than 5 marks. And it's useless for you to spend 15 minutes on a 5 marker. No, man, you can't do that. So look at what we're going to be using. We're going to be using the formula Sn is equals to A times R to the n minus 1 over R minus 1. We use the formula Sn is equals to A times R to the n minus 1 all over R minus 1. Where my first term is 1. My number of terms is 5 because it asks us to find the sum of the 5 terms. And my common ratio is 3. Sir, I see how you get the first term to 1. And I understand that the common ratio, the number of terms is 5. But how did you get a common ratio to be 3? By taking, I can't use the first term, because I don't have another term in front of the first term. So I have to use at least the second term. So I take the second term, 3, divided by 1, I get 3. 9, divided by 3, I get 3. 27, divided by 9, I get 3. 81, divided by 27, I still get 3. So anywhere I take this in this one, I'm getting the common ratio to be 3. Anywhere I check it, I'm getting the common ratio to be 3. Now, sir says, watch me. Sir says, once the common ratio is bigger than 1, see to yourself? We're going to use this formula. If the common ratio is greater than 1. If the common ratio is bigger than 1, we're going to use Sn is equal to A times R to the n minus 1 over R minus 1. Sn is equal to A times R to the n minus 1 over R minus 1. If R is less than 1, if R is less than 1, we still have the Sn is equals to A, but we're flipping this around. And when we flip it around, we have 1 minus R to the N over 1 minus R. So you need to be very mindful of your common ratio to know which other formulas you're using. But sir, what if R is less than 1, but I use this formula? Would I still get the same answer? Yes, it would. But it's just that we have negative numbers to work with. And I know my students don't like negative numbers. I know my students don't like negative numbers. So you're also saying, sir, that if R is greater than 1, I can use this one? But it's just that we have negative numbers to work with. So if you use the appropriate one, it will alleviate the negative signs. But whichever one you want to use, it works. All right, so let's go back now. So all I'm doing, in order to find the sum, is to substitute into the formula. Is to substitute into the formula. What I'm doing to find the sum is to substitute into the formula. A is going to be 1, so substituting 1. Let me see if I can put the formula down, so you can see them both. Here you go. So A is 1, so I'm substituting 1. Sorry, before I do that, N is 5. So you see, instead of writing Sn, I wrote S5, S subscript 5. Right. The 5 is the number of terms. So S subscript 5 is going to be equals to A, which is 1. I substitute the 1 there. And then I'm right here. And then R to the N. R is 3. So it's going to be raised 3 to the 5th power. The value of N. So it's going to be 3 raised to the 5th power. Minus 1 over R minus 1 over R minus 1 over R minus 1. What is R again, sir? R is 3. All right. So now that I've substituted into the equation, and evaluate.
So you can go back up and differentiate the one that you must use when R is greater or R is lesser than 1. That one you use when what, sir?
R is greater than 1, teacher. If R is greater than 1.
Okay.
And this one is if R is less than 1. Tell me if you're all right.
Yes, sir. Yes, sir.
Good. So 3 raised to the 5th power. 3 raised to the 5th power is 3 times 3 is 9, times 3 is 8, times 3 is 27, times 3 is 81, times 3 is 243. So 3 raised to the 5th power is 243. Minus 1, and of course the 3 minus 1. 343 minus 1 is 200. 243 minus 1 is 242. And 3 minus 1 is 2. And 242 divided by 2 is going to be 121. So we get back the same answer that we had gotten when we added it, the terms. But sir, if we get back the same answer, we could just go ahead and just add it and then move on. Except that in the exam, they're not going to give you such a question where the terms are very straightforward for you to add. I'm only giving you this to show you that the answer is correct from a teaching perspective. from a teaching and learning perspective, right? But outside of that, we have to apply the formulas. We have to apply the formulas. Very important. Any questions? Any questions?
Okay, not from me.
All right, cool. So note, the sum to infinity is found when r is less than 1. And we're going to be using the formula Sn is equals to a over 1 minus r. So once we're asked to calculate the sum to infinity, that's the formula we're going to be using. S infinity, that's the infinity sign. S infinity is going to be equal to a over 1 minus r. It's going to be equal to a over 1 minus r. A over 1 minus r. It's going to be equal to a over 1 minus r. Okay, moving. So recall, Sn is equals to a times r to the n minus 1 is going to be used if r is greater than 1. It's going to be used if r is greater than 1. And Sn is equal to a times 1 minus r to the n over 1 minus r is to be used if r is less than 1. If n is large, then r to the n approaches 0. And this gives rise to the sum to infinity to be equal to that. So when the common ratio is less than 1, and if n is large, when the common ratio is less than 1, and if n is large, then r to the n, when the common ratio is less than 1, this is the formula we have to use. And n is large, r to the n approaches 0. That means this value approaches 0. So all I'm going to have is 1 over 1 minus r and times a, which is going to be a over 1 minus r. So it gives rise to this formula, which is the sum to infinity. And that's why I'm saying that's the formula for sum to infinity. All right. Please note that the common ratio cannot be equals to 1. And I'm asking you, why is this so? Why do you think I'm saying that the common ratio cannot be equals to 1?
Sir, because we don't have any formula for that. If it equals to 1, it have to be less or greater than 1.
But look at the formulas again and tell me why you think that we can't have one that is equals to r, equals to 1. So look at both formulas I gave you and tell me why you can't have it equals to 1. Anybody, somebody. Mm-hmm. Look at the formulas again. Sn is equal to A times r to the n minus 1 over r minus 1 when r is greater than 1, or Sn is equal to A times 1 minus r to the n over 1 minus r if r is less than 1. Why can't r, the value of r, be equals to 1? Look at the formulas and tell me why we can't have r being equals to 1. It's right in front of you, trust me. Mm-hmm. Talk to me, no man.
So if the common ratio, it cannot be equal to 1, so would that mean there would be a common ratio?
No, I'm
If it's
saying
equal
the common ratio cannot be equals to 1. And I'm asking you, look at the formula and tell me why you believe the common ratio can't be equals to 1.
So if the no, sir, it can't be equal to 1.
Why?
The series would be constant then.
Why? Tell me why, no? Look
Sir,
at the
because
formula.
in the formula, sir, in the
Mm-hmm.
formula, sir, if you substitute the 1 in it, sir,
Mm-hmm. Mm-hmm.
you would definitely get 0 for the answer, sir.
Why?
Because, sir,
You're going somewhere, you know, so just go on, man. Just go on and stop if I'm but Johnny. Sure. Yeah, continue. You're going somewhere. And you're going in the right direction, incidentally. So just go on.
sir, because if you substitute the 1 in the formula, sir, and you raise it back to any power,
Mm-hmm.
it's gonna be 1.
Very
So
good. So,
you're gonna have 0 for the answer. Because 1 take 1, 0, and then you have the 1 down at the bottom, 0.
very
And
good, Danny. Very
yes,
good. Very, very, very good. And that's all I ask of the class, you know. I may sound difficult, but it's the nature of teaching. And I ask these questions just to know if my students are understanding. And that's why it's important for you to participate. Very good. So what Donnie is saying, sir, when I raise 1 to any number, my answer is 1. And 1 minus 1 is 0. And 1 minus 1 is 0. So it cannot be equal to that. It cannot be equal to 1. Right? So that is the explanation. That is the explanation. Very good. So the sum is going to be equal to 0. And the sum to infinity will be undefined because we have 1 minus, we have a 0 in the denominator for that. So just can't work. So the common ratio can't be equal to 1. Can't work. Can't find the sum, can't find nothing. So this could be a possible question on the multiple choice. Can the sum of the, can the common ratio of the, they give you something and, you know, they could give you something where the common ratio is 1. And people say, yeah, man, this is the answer, sir. And then you could say, no, but the common ratio can't be equal to 1 because you can't find nothing from that. So you have to continue determining which of which is the correct answer. All right. With that said, let us jump into some stuff because I don't want the class to be talky like you know, we want it to be like what it was last week, where I presented a lesson, then gave you questions to do, and then we come back and discuss the answer. So let me just go through the first one with you, or the second question with you, and then leave it to the sum, so we can just wrap up this topic. I really want to wrap up this topic by no later than 9 o'clock gone. By 10 o'clock-ish, I want to wrap it up so I can start something else. All right, let's go. Incidentally, next week is our final week. And then we have 1 week of revision. Let's go. The 6th term of a GP is 27. Wow. So this is only a AP question. What is the 6th term of a GP given by class? Tell me what the 6th term of a GP is given by. Question.
Sir, can you go, please, sir?
Me now go up because to the answer.
Sir, I never remember right.
So was it AR the first term times the common ratio and what was it? 5? It was a small 5 at the top for the 6th term.
Okay. Very good Taji. Hey, done. If I get this on my first, you know. So is it done? Taji, you got it? Yes. So the 6th term is going to be AR to the 5th. Right? Remember, the last term is going to be AR to the n minus 1. So it's 1 less than the number of terms. So if I say the 7th term of a GP is going to be AR to the 6th. All right. I remember doing this exercise last class. For the AP, let me do the exercise for the GP. What is the, how do I write the 100th term of an AP? Hello? Hello?
Sir, the 100th term, sir, so it's gonna be AR 99.
Very good. The 50th term is?
AR 50th 49.
Very good. The 12th?
AR 11, sir.
Very good. So it's just 1 less than the term, the number of terms. All right. While the 4th term is 3, what is the 4th term given by? While the 4th term is 3, what is the 4th term given by? Talk to me, no man.
Sir, yes, I was saying it's gonna be AR equal 3.
AR equals 3. Talk it again.
AR3 equals 3.
AR to the third power equals 3.
Yes.
Very good. Very good. So let us say it again now. So the sixth term of a GP, is going to be AR to the fifth equals 27. Say it again, sir. The sixth term of a GP is 27, is going to be AR to the fifth equals 27. And the fourth term is 3, we're going to have AR to the third equals 3. I feel in my spirit, guys, that you're going to get a question like this. And if it's not a GP, it's going to be an AP of this type. We have to use a simultaneous equation, like we did a lot of last class. I feel it in my bones. No, I have not seen the paper, but I feel it. Let's continue.
Sir, aren't you the one writing the paper, sir?
I prepared a paper, and the other community colleges in Jamaica also prepared a paper. And then when it goes to CCCJ, they mix up the questions. So sometimes some of my questions come, and there are times none of my questions turn up. So if I come and I say, okay, guys, here plan. This is a paper I submitted from to CCCJ, incidentally, which will never happen. It has never happened in the past, and it will never happen in the future. Chances are you're going to the exam and say, yeah, man, I must get my A because I said I'm going to practice the paper. And you're surprised that you're going to the exam is a totally different paper. Not one of the questions come back because they randomize the paper. Sometimes the submissions are not even used for that semester. It is used for 2 or 3 semesters later on down. All right. So we're going to solve simultaneous equation. So remember, I want you to think about indices. See if I remember indices now. So I'm dividing A to the fifth over AR to the third is going to be equal to 27 over 3. We're dividing. We are dividing. The A's cancel, clearly. For the R's, when I'm dividing and the bases are the same, I subtract the powers. And the sequence is numerator power minus denominator power. Numerator power minus denominator power. And it's going to be equals to 27 over 3. So 5 minus 3 is 2. So I'm going to have R and over R to the 0. And anything raised to the power 0 is 1. So I'm going to have R squared equals 9. I'm going to have R squared equals 9. And if R squared is equal to 9, that means R is 3. The common ratio is 3. And in order to find the first term, you're going to substitute it into any one of these. Substitute it into any one of those. To determine the first term.
So you said that you mentioned something about a numerator, sir. Can you repeat that, sir? That is how you got the 3 to be
the power in R.
The 3 and the 5.
Very good.
Okay.
So when you're dividing and the bases are the same, it's going to be the numerator power minus the denominator power. So it's going to be 5 minus 3. See there? 5 minus 3. That's a sequence when we're doing what we'll call it again? Indices and logarithms. When we're doing indices and logarithms, that's a sequence. Once you're dividing and the bases are the same, you're subtracting your powers. and it is the numerator power minus the denominator power. So I'm going to say 5 minus 3 is going to be equal to 2. And r squares is going to be equal to 9 because 27 divided by 3 is 9. So I'm going to have r squares equals 9 and find the square root of r squared to give me r, and the square root of 9 to give me 3. So I'm going to have r to be equal to 3, the common ratio to be equal to 3. And in order to determine the first term, I'm going to put r equals 3 into, I'm putting it in equation 2. I'm putting it in equation 2. It does not have to be equation 2. It could be equation 1. It doesn't have to be equation 2. It could be equation 1. It doesn't have to be equation 2. It can be equation 1. I'm going to put it there in equation 2. Equation 2, remember, was AR cubed. So I'm going to put A, 3 cubed, and it's going to be equal to 3. But 3 cubes is 27. So I'm going to divide both sides by 27. So I'm going to have 3 over 27. So I'm going to have A to be equals to 9. 1/9, sorry. A to be equals to 1/9. And that's how easy it is. And a question like this, sometimes a question like this comes to 12 marks, guys. Real hallelujah talk. When an exam and see a question like this, you say, thank you, Jesus. You win a paper and see a Kramer's, you say, Lord, bless you. Because it don't get easier than that. Don't get easier than that. All right. I think there's another part of the question that I asked you. The sum of the first 5 terms. Now remember, the value of r was not less than 1. So we're going to use a formula. Sn is equals to a times r to the n minus 1 over r minus 1. And we are doing the substitution like before. A is equals to 1/9. So I have my 1/9 there. R is 3. So I'm going to have my 3 there. N is 5, so it's going to be 3 to the 5th power. And over 3 minus 1. 3 to the 5th is same 243 minus 1. So it looks like we're getting the same 121, but this time A is not 1. A is 1/9. So we're going to multiply 121 by 1/9, and we're going to get 13 and 4/9. And that is going to be the sum of the geometry progression. The sum of the first 5 terms of the geometry progression. And that's it. Can they ask you to calculate the sum to infinity for this question? Can they ask you to calculate the sum to infinity for this question? Talk to me now.
Wait, sir, you only can work out the, isn't it that I can only work out the sum to infinity when 1 is greater than r?
When r is less than 1. But in this case,
yes,
r is
sir,
3. But in this case, r is 3. So we can't find the sum to infinity. So the question will have to end here. The question will have to end here because we can't calculate sum to infinity. All right. Do me a favor. I have a question there. I'm showing you what the answers are. but I want you to work it out to see if you get the same answer for me. I'm going to give you a few minutes. Oh dear. Can you do me a favor, please? Do me a favor, please. Can you just take a pic of the question? Just use the phone and just snap that question, please, so that I can project the questions that I've done before, so you can look at them as a guide. Snap that question for me, please. Question number 3, phone or tablet. Screenshot it, take a picture of it, whichever one you prefer. Let me know when you're done, so that I can project the 2 questions that I have done before, so you can use it as a guide. Somebody let me know if I can move the thing up, please.
Yes, sir. I finished screenshotting.
All right, so you see I have a full question there in the one that we just did to use as a guide. Start working for me, please. I'm going to step away for 2 seconds. never true. Aye. Finished? Hello,
Oh,
somebody?
sir. Oh, sir,
Oh, you're
I'm
not
looking
finished
up
yet?
question. Yes, sir.
You're finished, Tajay? That's what you're saying?
Oh, no, sir. I'm
All
working
right.
on
I
the
give that,
question.
all right. I give that a
Sir,
couple more minutes. Go ahead, Danny.
yes, sir, I was telling you that I finished, but I think something is wrong.
You think something is wrong? All right.
Yes.
Assume look at that. I want to give Tajay an opportunity to just finish off his. So I give Tajay 2 more minutes, and then I look at it together. All right? That's all right, Danny?
Yes, sir, no problem.
All right, cool. Taji, that takes so long.
Also,
Gosh.
2 more minutes. I'm at the last question.
All right, hurry. All right, Donnie, while Taj continues to work, matter of fact, let me just check something. All right, while Taj continues to work.
What you said, sir?
No, I'm just saying, while Taj continues to work, I just remember that I didn't do the question. I mean, I did the question, but I didn't project the solutions. I'm asking you, did you get 2 for your common ratio?
Yes, sir, but it wasn't a -2.
No, it's not a -2. Ha ha.
Sir, come on, sir. Sir, I was like, me I do it, and me I say no, man. Probably sir make an error. Cause me I say I get everything but except the negative. So me I look over me and say, probably something wrong, but me I wait, come the things say something wrong, honestly.
I love it. So you got the 1A?
Yes, sir.
Oh, you get everything.
Negative, yes, sir, but it wasn't a negative number.
Good. It's nice when the teacher can just trick. Well, it wasn't intentional. I just put answer. Wait, don't you know that I teach at this hour? All right, hold on 1 minute, please. This is America call. Students, pray for me here. I'm having a one-man conversation. I'm going to say to you, say, "Una talk to me, no man," and recognize me mute. Forgive me. Let me go again. Taj, have you gotten all the answers, the 2, the 1, 8, the 3, and 7, 8?
Yes, sir.
Nice. I only recognize that there are other students in the class, and I'm not hearing from you guys. It's not nice. It's not nice for the teacher to be teaching and the teacher asking questions and I'm not hearing anything. I mean, not even a message in the chat to say, "Boy, sir, I'm at work. I can't speak," or But anyhow, let's go. All right. So I'm proud of you. Now, I have not yet done that one, but never mind. I'll get it done up quickly. I'll do it while you're doing it, just like we did last week. Come on. Numero cuatro. Number 4. Number 4. Start for me, please. Number 4. Where's my pen and paper? Number 4. Start for me, please. And guess what? We're now going to 10 minutes to do the question, Quick and fast. Quick and fast. Start. The fifth term of a GP is 1. While the third term is 16. Fifth term. The third term is 16. Mm-mm. R, that's R. All right, so I finished with my question. Anybody do the first part? Have you calculated the common ratio?
Yes, sir.
What you got for the common ratio?
So 1/4.
Very
Quarter.
good. Very good, a quarter. Excellent. Anybody finish the first term? Talk to me now.
No, sir.
All right. Anybody get the first term? I want to know before I do it. So that's how we do the common ratio. Anybody get the first term?
Sir, I got 256 for the first term.
Mm-hmm. We get honey.
I got the same thing.
Okay. That's correct. All right, move on. I'll do the solution for that. Move on, please. What is saying find it about the A?
Sir, repeat what you said about A.
No, Colin, it was saying something to me about A.
Oh.
Okay. Where am I looking? Where's my pencil? Where's my pencil? Okay. So, anybody finish the third part? What's the answer for the third part?
The sum of the first 5 terms, sir.
Mm-hmm.
All right, so 87,296 I got.
Okay. Anybody else? Anybody else for the sum of the first 5 terms? Double check that for me, please, Donny. Look, Donny, and tell me that's what you have. Hmm.
Sir, wait, sir, I was looking. No, sir.
Mm-hmm. Try again for me, please.
Yes, sir. Sir, the screen is blank.
Oh, sure. I mean, Oh, my sweet Jesus, help us. When don't make me drop asleep, you know. Don't make me drop asleep.
So I don't know what I'm doing wrong. So I got back the same answer.
So you have you use what it is that I have on screen.
Yes, sir.
All right, let me finish type it then. What you got for 1/4 raised to the 5th power as a fraction?
Yes, sir. You said so I got 1/1024.
Mm-hmm. Very good. And then what is 1 minus a quarter?
I got 3/1.
0/4.
Plus
1 minus 1
no,
quarter
yes.
is
Mm-hmm.
0/4. So that's where the error is.
Yes, sir.
All right, fix it in 2 minutes and then let me hear what you get.
Mm-hmm. Sir, 341.
On that third, apparently.
Finally. Finally. Not that I didn't want to be, but I really want to give you an opportunity to do the questions and find your own errors. Finally. All right. Go ahead with the sum to infinity for me, please.
Okay, sir.
All right, so that's what it looks like. What's the sum to infinity? Nobody finished that one? We're taking up quite a while for this. And I think I want to give one more, a final one, and then I'll close out the topic. I think you guys are understanding, just that you're working a little slow.
So the same answer where I get for the sum of the first 5 terms, I'm getting for the sum to infinity as well.
I didn't get that. I got something different. Check again, Taj. That's what you use, Taj?
Yes, sir.
All right, check from there for me, please. I'm noticing something, and let me just speak about it. Because this question, the common ratio here is a fraction, people are having a problem. When the common ratio was a whole number, the question was done quicker. The question is a fraction now. People start making a lot of computational errors. So you have to work on those fractional skills. Please, 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 please.
Sir, is it 341 and a third?
Thank you, Tash. Thank you. Yes, it is. Yes, it is, Papa. All right, so that's what the answer looks like. 341 and a third. $341 and a third. Are we okay? Are we together?
Yes, sir.
Yes, sir.
All right, last one, last digga one, final one. Final one. where we stay? Where are we? Finished?
No, sir.
Anybody got the sum for the first 10 terms yet?
No, sir, I'm almost finished with it.
Okay.
Sorry, sir. Sir, I know I did work it over back in a sir, but I think that's what I got.
That's what I got for my
So I put it as a fraction. I put 3 and 9 over 10 because it does say 0.99.
Okay, that's fine. Very good. What's the sum? I mean, infinity. Come guys, it's 11 o'clock. Tell me.
So is it 4?
Very good. Very good. All right. I know, I'm coming. All right. We're going to take a break from APGP. I've completed the topic now. I've completed the topic. We have an hour left, and I want to start and finish my graphs. I want to start and finish my graphs. So I'm going to change screen. And I'm projecting a new screen. So I want to seal APGP, seal it up, bag it up, lock it away. We're done with that. There are 8 areas for the precalculus. We're finished with indices. We're finished with logarithms. We're finished with binomials. We're finished with sequence and series, which is APGP. We're finished with Kramer's. And now I'm starting my graphs. And I have polynomials. And hold on, I think I'm missing something. Hold on. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right. So I'll have polynomials and, some functions and relations. to look at. The functions and relations is really not bad. That can be done in a limited time. That is just a reminder of what it is that we do with equation of a line, the gradient of a line, and talk about some cost function. Matter of fact, which one I think I should have learned? That one is easier. Let me just finish off this one. All right, yeah. So let me go back to my screen. So we're going to be looking at that. So we've done the indices, we've done our logarithms, we've done our AP and GP, we've done our Kramers, we've done our binomials. We are on to now function graphs, and then we have 2 topics left. And the 2 topics that are left are pretty simple. By the way, did we do polynomials? Remind me. Which is a long division. Did we do those? Hello?
I don't think so, sir.
Okay, all right, no problem. But it's not bad. So we have two simple topics that are left, and I can finish those 2 simple topics next week. Pretty reasonably easy. Reasonably easy. All right, it's just that we were struggling. I would have finished already, but I was struggling to get with the class, to just get the class going, and you know, so we were behind somewhat, but never mind. We will catch up. We will finish in preparation for the exam. So fret not. All right, graphs. Now, I'm going to be teaching this topic by doing examples. Why, sir? We've been doing graphs all our lives. CXC, Foundation 1, 2, 3, and now Precalculus. So I'm gonna. I've chosen to just look at the examples. So look at this one here. It says graph the function of y equals 2 to the x plus 1 for 0, x greater than or equals to 0, but less than or equals to 3. When you see the range of the graph is telling you how the where the graph is bounded, won't pass certain things. All right, and certain values, not things but values. So what we need to do whenever we're doing, what we need to recognize, sorry, whenever we're doing our graphs, more than likely it's going to be either an exponential graph that we're going to be plotting, that they're going to give us a plot, or a logarithmic graph. So they will give you either an exponential graph or a logarithmic graph to plot. And we'll be doing examples of both. So look at what it's saying. So it tells us that our domain there is going to be 0 to 3 inclusive, and we need to calculate the range of the equation. All we need to do is to determine the domain. All we need to do is to determine the domain. Once we have determined the domain, things become easier. Once we have the domain, we substitute the domain into the function, evaluate it, we get the range. So anywhere in the function you see x, you're going to put 0. That's what it means. Anywhere in the function you see x, you're going to put 0. You must have your calculators with you. Anywhere in the function you see x, you're going to put 0. What is 2 times 0 equals to?
Sir, 0.
Very good. So that is going to be, you're just going to have 1 in the numerator. Sorry, 1 in the power, because e to the 2x plus 1, if x is 0, you're going to have 2 times 0, which is 0 plus 1, which is 1. So you now need to evaluate e to the first power. Look at your calculators. Tell me if you're seeing the e on the calculator. If you're seeing it, press it, and then put one side of it, and then press equal and tell me what you get.
2.71, sir.
Very good, 2.71. If you're not seeing it or don't know how to evaluate it on the calculator, please say something. Say something, because you may very well get the exponential function to put in the exam. You may very well get the exponential function to put in the exam.
Oh, sir, so you're just substituting the x values into the formula
Very good.
on up top.
So go ahead and substitute the other values in there for me, and tell me if you get the values that I have for y right there. So, and then I'll take it from there. And you can see what it is that I have done. Y is equals to e to the 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3, so we have e to the 3. When I reach 2, put in 2, 2 times 2 is 4, 4 plus 1 is 5, so we have e to the 5. When it's 3, I'm going to have 2 times 3 is 6, plus 1 is 7, so we have e to the 7. When it's 4, we have 2 times 4 is 8 plus 1 is 9, so I end up with e to the 9. Use those, put on the calculators. Tell me if you get what I get.
Sir, I got them.
Good job. What about you? What about you, Taj, and who else is here? And calling it?
Oh, sorry, same.
Yes, sir, I got them.
All right, good. Now, no, I'm aware that you may not have not a calculator, but I would hope you have a calculator. I'm aware that you may not have a graph paper, but I'm going to go through nonetheless with you, and then you're going to try and put these on a graph paper at some point in time later on. Right? It's important that you know how to actually put it on a graph. Now, so look at what is happening here. And if you have to zoom, please to pinch and zoom into your stuff. So in order to plot, I am going to, let me see if I can put control. So all right, so all right. All right, so we will have x equals 0. X equals 0 is anywhere along the crosshairs. X equals 0 is anywhere along the crosshairs. And x equals 0 is anywhere along here. And then y equals 2.71. You're going to go up on the y-axis, and you're going to estimate where 2.71 is. You're estimating where 2.71 is. So you're going to look to see how the graph is calibrated. You're going to look to see how the graph is calibrated. You're going to look to see how the graph is calibrated. So if this is 1, it means that each spacing is going to be 0.2, 0.2, 0.4, 0.6, 0.8, 1. 1.2, 1.4, 1.6, 1.8, 2, 2.4, 2.6, 2.8. Now, because it's 2.71, you know, it is between 2, 4, 6. You will see that the value here is 0.2, 0.4, 0.6, 0.8, 2.71 falls between 0.6 and 0.8. Can you agree with me?
Yes, sir.
Mm-hmm. So it lies between those. All right. Then we have when x is 1, y is 20.8. Lord have mercy. Lord of mercy. This graph don't show it. When x is 1, 20.8 is all the way up here, so that comes off the graph. So you're not seeing that one, but you get the gist of what I'm saying, though, in terms of plotting the graph. Maybe this is not a good example to show, because when it is 1 and 3 and 4, I didn't even realize what it is that I did. I did a -2 and -1. What I should have done is on the 1 and the 2. So I need to change graph. Lord of mercy, I did a boo-boo.
So you're saying that the x values you should have plot 1 and 2 and not -1 and -2?
Right, yeah, because remember the values
Also,
that
it should
I
be on
use.
the other side.
Right.
So as it regards to the one that just the 2.71 that you just calculated, sir, you said 2.2, 2.4, 2.6, 2.8. That's what you
Right,
said?
2.8, right. And
So
2.8 is about
4?
so
No,
so
not
up
4, 2.
between 2.6 and 2.8.
Yes, sir, but I'm saying that you what did I say? You're counting by 2 with the original. Yeah, you're counting 0.2.
Right. So it's gonna be 2.2, 2.4, 2.6, 2.8. Yeah.
All right.
I mean, I reach up here, so now we move to 3, 3.2, 3.4, 3.6, 3.8, 4, 4.2, 4.4, 4.6, 4.8. All right. I think this is maybe
So that's always the case, sir, when we're doing E.
yeah,
By
man.
2.
And
Okay.
always the case when you're doing any number, anything.
Really?
Yeah, man.
Right.
Always the case. Do me a favor. Anybody have space on them phone? I want you to download this for me. Desmos Graph. You don't have to download it, but if you can, it would be nice if you download the app. It's free. If not, see if you can go to Desmos Graph for me. And we're going to put in a function. So you're seeing my Desmos Graph on the thing. And no, you're not seeing it. Y equals e to the 2x plus 1. Y equals e to the 2x plus 1. All right, you're seeing it now. So look at what I'm doing. I'm putting in the function. Y equals e raised to the 2x. I'm going to that thing here. Raised to the 2x plus 1. Nope, my plus 1 is up top. Plus 1. Nope, that's not it. Plus, nope, no, sorry. Got to put it in parentheses in order to get it. Plus 1, close my parentheses. So that's what it looks like. So that's what my graph looks like. Let me just show you now. Let me bigify it a little. Let me close this for 1 minute. Oh, come on. Undo. That's not what I meant to do. Hush. I meant to minimize it right here. All right. Now it's in the whole thing. So what I'm saying is when it's 0, it's 2.71. It cut it right here. So
Yes, sir.
When you click on it, you see you get 2.71.
Yes, sir.
Right, that's a 2.71. All right. And then when it is 1 now, this graph is, oh Lord. Maybe that's how I didn't do it. When it's 1, it's going to be 20 point, how much?
8. Oh, see there, sir.
Right here, so?
Yeah.
Yeah, something like that. Right?
So, so oh, you put the E in the thing.
In the thing, oh, no, let me just go back to default. It's not bad. Just write E from it on the computer. Or when you go down to here, to this piece on the bottom here, and you click on it, the toolbar, you can go to ABC and click E from here. See?
Yes, sir.
Yeah, man.
So, and then how you get the first?
So I get the what? Not hearing you, hon.
So I'm trying to do it on the
Yeah. So
look at the
yeah, that's what I want.
parentheses, sir.
Yeah, that's what I want to do. I want to play around with it so you can see what is happening. I can move on now.
Oh my graph of on. Oh. All right, sir. Yes, sir. You can move on.
All right. What I want you to do for me. I want you to. That's why I'm going to take off this here. I understand why it is that I had it like that, because if I didn't put it like that, you're not going to see the graph going to be way too long. So that's why I put it like that. Now I can understand why I put it like that. All right. This one is a little better. Not a whole lot better, but we're getting closer to where we can see the stuff. It's just that I want to give you some exponential ones so you can see what is happening. Do me a favor. I want you to go ahead and plug into your calculators those values, see if you get them, and then we're going back to Desmos to plot the graph online to see what is happening. My aim here is for you to know how to use your calculators. It's very important, very, very important that you know how to do that. So you have a new function. The function is going to be e to the x and then plus 1. You notice the plus 1 is not in the superscript. The plus 1 stands alone. Here's a point I want to bring across in this graph compared to the graph before. F of x is equal to e to the x, which is one function, plus 1. So you have two terms in it. In the first one, we just had one term. We just had e to the 2x plus 1, just one term. This one now has two terms. And that plus 1 is speaking about the translation of the graph. So that plus 1 is telling me that that graph is translated 1 unit upwards because it's a plus 1. And I'm going to play around with this graph to show you, had it been -1, it would have been translated 1 unit beneath the graph. So go ahead and do when x equals 0, 1, 2, 3, and 4 for me, as the domain says. And then we can have a conversation on that thereafter. I give you a few minutes. I want you to hurry up with this one here because I really want you to just go through the graphs today. It's really not difficult. It really isn't difficult. The most difficult part of it is to calculate the thing. Say it again.
This is the topic just
Where's,
punching in the x's and plotting the graph. This is it. This is it.
that's it.
Don't go
That's
any
all.
further. All right.
It don't, let me tell you how much further it will go. Sometimes I will give you 2 graphs to plot on the same graph paper and ask you to find a solution. That's the furthest they will go. Give it 2 graphs to plot and ask you to find a solution. And guess what? That is not a problem because it does give plot 2 graphs on the same graph paper, and wherever they intersect, that is the answer. So you don't have to do no calculation at all. It's just a graph you plot in, and all the answers that you will get for the question will be read from the graph paper. Will be read from the graph paper. And because we're doing an
So
online
sir,
exam,
they would like give you the graph paper and tell you to find what is y or what is x.
right. So, and I was saying, like with an online exam, your graph will be electronic. So you'll see the electronic graph on editor that comes up, and you work from there.
Okay.
But you still need to know how to plot the graph. And also to know what the general shape of the exponential graph looks like. It's not a U, it's not a C, it's like a little, we call that L. What shape will you call this?
Like quarter of the circle.
Well, or something like so. Whatever shape it is, just remember what shape it looks like. Because if you're doing it online, they may give you a series of graphs and ask you to select the basic graph. And the basic graph would be this, what we're looking at here.
On the that
If you're talking, Danny, I'm not hearing you. Wasn't hearing you.
All right, sir. So I was saying on my graph, sir, I don't have that shape, sir, but I'm thinking that is the plottings. That's it. No, not plotting.
Okay. Look in your function. Look where you put in the function and tell me where is you have the e to the x?
Sir, not the one. I'm talking about the one before, sir.
Oh, we they plotted to those to that one?
No, sir. You know that the value is -1, -2. I don't have that. So I think that's the problem.
-1, -2.
Yes, sir. Like you leaving the graph.
Are you using a computer, Danny?
No, not the computer, on my phone.
Oh crap. Are we having a class on my phone?
No, sir, on the computer.
Oh, you want to do it on the computer and then share your screen so I can see what it is, please?
So how would I? Oh, I just
go to www.desmos.com.
Okay.
I think desmosgraph.com.
www.desmosgraph.com. I see something come up, worksheet document generation software
Share your
0.
screen for me. Let me stop sharing and share your screen for me, please. Hold on.
Someone know what is this?
Let me just check on. No, don't go to Desmos Lab. Just go to desmos.com. Desmos.com. And yeah, desmos.com. You can go ahead and share.
Okay, sir.
Yeah, right, here you go. All right, put it in the function now.
It was y equal.
Click on the tablet, right? ABC, good. E. Good. Go back to 1, 2, 3 now. No, you don't press E yet.
I'm pressing it, I don't know what's happening.
Pressing it?
Yes, sir. I
All
don't know
right,
what's happening.
all right, go back to 1, 2, 3. Press E on your keyboard. All right, and press the A to the B to get A to the B. Other one, right, to get the power. Press on that. You pressing it?
Yes, sir. I don't know why it's not pressing.
Something wrong with the keyboard. All right.
Yes.
Press the upside down V over 6 on your keyboard. Just press shift.
Right down. V.
Maybe that's why it's not different graph.
Sir, where is that? Upside down V.
Right. Over the number 6.
I don't see any V over here, so sir. So you're talking on the screen or on the keyboard itself?
On the computer.
I don't see any V, sir. Upside down V. Let's see if this still not pressing.
All right. You know how to give a control on your thing?
I think you have to ask for access, sir. And then I would necessarily have to click control, let you control my screen. Don't.
Let me see if I can ask for you.
I don't V. When I was on my phone, sir, was going in. Yes, sir, I did it on my phone, but it's just that the numbers were different. So
I'm not seeing the control.
So I guess you have to click on, okay, so I think I can give you remote control. So it's which one of the mark shand?
Good question. Because I'm logged into 2 devices. Are you seeing? Oh Lord. Oh man. All right. I'm going to. Oh, give me the one that not the one that you see the microphone on, because I disabled that. Give me the one that is disabled, that the microphone is not on. Not the one that is moving now, the other one.
Just a minute, sir, because I'm not seeing it. So I'm not seeing it, sir. Just gonna try and give one of them.
Yeah, try and give one of them. Let me see what happened.
Waiting for, so it's waiting for you to control screen. And tell me if it's the other one. You seen it, sir?
No, miss. The devil is a liar. I cannot see nothing.
All right.
Try the other one. All right. So all right. All right. But I pressed and I got it. 2x. I have to put it in parentheses.
So you say you're not pressing anything on the keyboard?
Is the keyboard
on the screen? Or it's on your keyboard itself you're pressing?
Yeah, it's my keyboard I'm pressing to do it.
Oh, okay.
I'm not pressing anything on the keyboard. Let me just lower that keyboard. I'm not pressing anything on that. It's a keyboard on my computer that I'm using. Okay. So that's how I got that one. And then if I want to plot the other one, I can just go and say E. I'm pressing Shift and the number 6 to get the power up there. That's what I did. Shift and number 6. And that one was X. And then +1 down here. So now I'm seeing both graphs color-coded. One is, the first one is red, and the second graph is blue. The e to the x is blue, so you know which is which. Yes. Now, what I was saying to you is that this graph, the blue graph, is translated 1 unit upwards. Let me just change the axis here by just stretching it. Instead of pinching, I'm just using the keypad and just stretching until I get the thing to be 1. Come on, stretch, good. So I'm stretching it out until I get 1, just to show you that
so you just separate the fingers, your 2 fingers, like
I just separate. I just put my fingers here and just separate them, move them apart instead of pinching. I'm moving them apart. Sir. Yeah, man. Okay. So when I do that now, I can tell you that the blue graph e to the x plus 1. Sorry, let me just do another plot to show you what e to the x looks like. Shift number 6, and then I press x. All right, so e to the x is a green graph. It's important for me to show you what e to the x is, to show you what e to the x plus 1 is. E to the x passes through 1 on the y-axis, as you can see in green. Yes, all right, and why, sir? Because anything raised to the power 0 is 1. So e to the 0 is 1. E to the 0 is 1. So once you get the exponential function, e, it will pass through 1. E to the x, that is going to pass through 1. If you get e to the x plus 1, it's going to pass through 1 and then go up to another 1, because this one is saying that this graph, look here, this graph, e to the x, if I put e to the x plus 1, it's going to translate up to here, 1 unit upwards. Watch me. If I put e, shift number 6, x plus 2, Look at the purple graph. The green graph is e to the x.
Unit up.
Right. The green graph is e to the x. If I say e to the x plus 1, it's going to jump to one more. It's going to jump to one more, right? Because it's translated 1 unit upwards. If I say e to the x plus 2, it will jump one more, so it goes up to 3, right? But what if I put e to the x minus 1? Tajay, are you with us?
Guess it's gonna go below, sir.
Very good. It has to move below. E to the x minus 1 is going to, is right. So remember, e to the x, must pass through 1. So e to the x minus 1 will pass through the origin. You follow me? Because the graph of e to the x must pass through 1. Why, sir? Anything raised to the power 0 is 1. So it must pass through 1. Fair enough?
Yes, sir.
All right. I'm giving my cup control, so you have control of it, Stop share for me, please. Let me just show something. Thank you.
Yes.
What I want you to do for me is to try this question. This question is a little nicer to deal with. And this is a question like what you can get in the exam. So I want you to try. You don't have to do the actual drawing up the table and so forth, but I want you to just take your calculators out, try those calculations for me. I have done the calculations for you so that you can see what they look like right here. So this is to the negative 1. This is that is to the negative 1. I can take off one of these spaces. That is to the negative 1, 0, 1, 2, 3, 4. So I've done all the calculations. I want you to just see if, oh, come on. I want you to just see if you agree with the stuff. Go ahead and try those calculations for me, please. How is the talk to me, no students? How is the
Okay, sir.
let me know when you finish, please. My main aim for this exercise is to just for you to know how you manipulate your calculators to get the answer. Work with it to see if I get the same answer like you have gotten. Good thing I did that because Sidani wasn't getting something right on her system in order for us to sort it out. This tool that I'm introducing into Desmos graphs is not something that you can use in the exam, meaning that you can't plot the graph in Desmos and then upload to me because you'll get 0 for that. But at least you can have a tool where it is that when you're practicing your stuff, you can see exactly what it works out to be. So it's a very useful tool. So for those of you who I may or may not get for business calculus, again, you will see me use this graphing tool, so we can do our stuff with piecewise functions, etc., etc. Stationary points. So I use it a lot for my calculus courses. Let me know when you finish. We don't have much time, and I want to just wrap up before the time runs out. Oh, Rockstone. Time has run out. All right.
Sir, so you're teaching business calculus for the next semester?
I don't know if I'm going to be timetable for business cal.
Mr.
So
Nichols to teach business calculus?
he can, but I'm not sure if he is timetabled either. I so far I know what 2 courses I'm teaching. I'm teaching 3 courses this semester. I am carrying 2 of the same courses. Well, I'm teaching a CAPE course. I'm going back to finish off the CAPE syllabus. And I taught Calculus 1 to the computing students, and no, I'm done for Calculus 2. I'm not sure if I'm going to be done for business calculus or Mr. Nicholas. I don't know yet. I'll have to wait until maybe this week into next week to find out who will be assigned the business calculus class. But don't worry about it. You will definitely get somebody who can and will take you through the strides patiently too. All right.
Well, I said, well.
I don't like that well, you know. That well looks deep. It looks and sounds very deep. It looked like when, you know, for this year, well, I went to Brownstown Community College, drove up to Brownstown Community College, and right in at the front of the school is a well. I mean, I said, so what? Them couldn't put the well somewhere else. But of course, the school is the institution is old, and they have a big well at the front, and then put a mesh over it so that at least nobody falls into it and you know, debris and so forth. You see, when me look down at something, there is no bottom. It looks bottomless. Me don't even go close to it because next thing breeze go blow on me, go lift up and drop down in there. Me say no, no man. I appreciate those people who come from country who have to use bucket and rope and send on them rope to get the water and carry it up. Negative. Me a town man. Me know about turn on pipe and get water out of pipe. No deal. But yeah, don't worry about it. It will be fine. Business calculus is easier than pre-calculus because business calculus is just integration and differentiation that you're using and their applications. Business pre-calculus go through a whole lot of something, 8 different areas. Pre-calculus focuses on, business calculus focuses only on 2 areas. Integration.
Some students were telling me that it's a bit hard, but
no, sir.
I don't really take the word for it, sir, because remember, I'm not doing it as yet, so I can't really say I'm going into the class thinking that, boy, them say it hard, you know. So more see for myself. But then again, the teacher have to be someone who must sure say, all right, then.
Yeah, and that point is well taken. The teacher has, whether or not you're doing an easy course or a hard course, it depends. You suck the teacher's energy. That's the point.
Yes,
you know, the teacher comes to class with the vibe. Trust me, you're gonna want to learn. All when it's hard, you're gonna want to learn because the teacher give you a vibe to learn.
He said,
right?
You know, Ashley, sir. I think she named Ashley Williams. Ashley.
No.
So she say ERG, sir.
Which
she was
course?
telling me that I guess she did it last semester, sir. And she was asking me who was my pre-cal teacher, so I said Mr. Sean. So she said, oh, Mr. Sean, my G man. I say him nice.
No, I don't remember Ashley. Oh Jesus, I have had so many students that trust me. And one of the things I can say to you, I will say to you is most of my best friends in this life as I speak to you today are my past students. I mean, I have some very good past students that funny story, quickly before we go. I'm using my headset that I use for class was broken. And out of the blues, a past student that I had from about 2003, 2004, just called me out of the blue, sir, I'm coming to Jamaica. You need anything to carry down? And I said, strange. I said, yeah. I said, all right, let me go to Amazon now, because I mean, I already have his address because there's a student that I keep in touch with. I said, let me go to Amazon now and buy the stuff them and send them off and say, all right, do it quick because I don't know which day I'm going, but it's one day next week. I can just up and go. He works with the airline, so he can just be at work and decide, say, you know what, I'm going to Jamaica and just fly to Jamaica. I don't need any passport because I can just use him ID and come to Jamaica.
Yeah.
And I bought it. It was delivered like today, and tomorrow in fly out. So I got the stuff in within a week. I got the items that I purchased. Point I'm making is some of my best friends in this life, as I speak today, we laugh and talk and we go out and we do are my past students. And the truth of the matter is because of how I treat with students. I don't play with my students. I will get miserable on you and I'll cuss you out. But guess what? It doesn't change the love at all that I have for my students. It don't change the love. It not change it. When I cuss you out and I get vexed at you, it means that it's because I want the best of you and you're not giving me the best at that point in time. But don't worry about it, man. You will be fine. The business calculus is really not difficult. As long as you know how to integrate and differentiate, you're good to go. I promise you. If you have if it's lie me telling you know how to contact me, don't touch base with me and say, sir, you did tell me one lie. And I can show you 1 or 2 ropes. And by the time I explain the 1 or 2 ropes to you, I promise you will get back on track. All right.
Yes.
But
Yes,
anyhow, I don't want to hold up another class who may be want to use this Zoom link. So do the stuff, look over, please, guys, start studying. Start studying and you book up on something. Just drop it in the group now and say, boy, sir, XYZ, and then I can throw it out and ask other students to see if they can answer it, or I'll just come in and answer it. This is a time now we need to do our revision for our finals. Start a revision from now. All right?
Yes, sir.
Okay, bless up. Take care.